This lesson is going to talk about the different types of expressions. There are two different types of expressions that we're going to talk about. One is the algebraic expression, and the other is the verbal expression. An algebraic expression is basically an expression with variables. So if an expression has letters within it, it's called an algebraic expression. It also has other items like numbers and operations within it as well. But the key thing to know is that if it has a variable, it's called an algebraic expression. The other one is called a verbal expression. A verbal expression is basically taking that algebraic expression and saying it in words. So you'll see that I have examples for both types of expressions listed. So for the algebraic expressions, we have examples like 2x plus 6. You'll notice that there's a variable in there. And 5x, you'll notice that there's a variable in there. And then for the verbal expressions, you'll see that under our examples, we have words, twice a number plus 6, or 4 less than a number. And what we're going to be doing today is we're going to be translating back and forth between the two. All right, before we go ahead and translate these back and forth, I do want to take a look at this. And it says, determine the expression. So up here, you can see that we're given this little thing that we like to call a key. Sometimes this is also called a legend. So if you hear the word legend, it basically means the same thing as a key. It's saying, what did these two items represent? So the rectangles we can see represent the variable x, and the square represents the number positive 1. So what we want to do is we're given this big cluster of rectangles and squares, and we want to figure out what is the expression that is being represented. So what I want to do is basically count up the rectangles. In number 1, it looks like I have 4 rectangles. If each rectangle represents an x, well, I have 4 of them. So I have 4 x's. And then if I count up the little squares, remember they represent a 1, I have 1, 2, 3, 4, 5, 6, 7. So positive 7, so I'm going to write plus 7. So this is the expression that represents this cluster of shapes. All right, and number 2, we're going to do the same thing. We're going to go ahead and count up the rectangles. So it looks like I have 1, 2, 3, 4, 5, 6, 7, 8. I count 8, so I have 8 x's. And then I'm going to go ahead and count up the squares, and it looks like I have 2, so positive 2. So this is my expression that is representing my figures. And just as a reminder, the difference between an expression and an equation is basically the equal sign. If you have an equation, which we'll talk about in Unit 2, you have an equal sign. But in this case, Unit 1 is all about expressions, so therefore there will be no equal sign. Okay, on this next page, I would like you to fill out some information within these spaces. But we're going to be looking at the mathematical operations and symbols that are that we use to identify the word addition, subtraction, multiplication, division. And so basically words that when you see that word, it means addition or subtraction or multiplication, division. Then we're going to talk about some turnaround words, and we're going to talk about what happens whenever you have parentheses. So what I'd like you to do is, as we talk about these, I would like you to go ahead and fill in what we talk about in these spaces. But you'll notice up on page 1 of your packet, I actually give you some information. These are the most common words that we see for these 4 operations. And you'll see addition, we're going to use, or we very commonly use these terms: plus, more than, the sum of, the total of, increased by, and added to. So anytime you see plus, like 3 plus 8, okay, that means addition. Or 3 more than 8, that means addition. Or the sum of 3 and 8, that means addition. Same idea. Subtraction. Here are the ones that we most commonly use for subtraction: minus, less than, the difference of, less, decreased by, subtracted from. Those are all ones that are very common, like 3 minus 8. 3 minus 8, well, that's subtraction. 3 less than 8, that's subtraction. The difference of. Difference is definitely a very common one, but also very misused. So keep your eye on the word difference. That means subtraction. And then so forth. Remember, at any time during these videos, feel free to just pause it and, copy down these words in your notes. It's a great way to help you remember them. Okay, multiplication. Here are the most frequent ones we use. We use times, the product. Product's a big one. Twice, double, triple, quadruple, and so forth. Multiplied by, and of. Of is definitely a tricky one. So 3 of 8 means multiplication. And the last one, division. Here are our frequent terms. The quotient of. Quotient's a very popular one that we use. Divided by, 3 divided by 8. And the ratio of. A ratio, again, is just, it's another way to represent a fraction. So the ratio of 3 over 8, that is representing division. There's a little bit more on this page here that we're actually not going to talk about today. We're going to talk about in the weeks to come. But go ahead and feel free to pause the video and copy down some of these terms here so that you can use your notes to help you study. I'm going to go back down and we're going to start translating. So when I translate expressions, I like to do this thing called annotating, and I'll show you what that means. So if we look at number 1, here's what annotating, here's what it looks like to annotate. I'm literally going to write what it says right above the word. So 4, I'm going to actually write a 4 there. Increased by. We talked about increased by. That phrase right there, that means increase. And then a number. Well, if it just says a number, we don't know exactly what the number is. So when we don't know what a number is, we can just call it a variable. And I'm going to use the variable x. Feel free to use any variable that you like. So what I did there was annotate it, and what it does is it yields the answer. So my expression, 4 increased by a number, is just going to be 4 plus x. You can see that my number 4 is being increased by the letter x. Okay, the second one, 12 less a number. I'm going to go ahead and annotate 12 less means minus, and then a number, well, let's go ahead and use x. So 12 less a number is going to be 12 with a subtraction sign and my number x. The quotient of a number and 8. Okay, let's go ahead and do this. The quotient. Well, quotient is division. The quotient of a number and 8. Okay, so this is a very interesting one because up to this point, you probably used this symbol divided by that I'm circling here. You probably use this to represent your division. Well, as we move into more complex topics in algebra, we're going to start wanting to use the fraction bar instead of the division symbol. So, the quotient of a number in 8, I would represent like this, x over 8. And I would appreciate it if you did represent it like this. It's kind of taking it to the next level. If you represent it like this, it's not necessarily incorrect. It's just in middle school and in Algebra 1, we like to represent it using the fraction bar. Okay. One more thing I want to say about that. You'll notice that I said the quotient of a number. A number came first. So whatever comes first is going to be the thing that goes on the top in the numerator of the fraction. And then the second one, which is our 8, is going to go in the denominator, the bottom. All right, let's move on. 12 minus double a number. Okay, let's go ahead and annotate. 12 minus double. Double's that multiplication word. We also know that when you double something, you multiply it by 2. So I'm actually going to do this. I'm going to say times 2, just so I know that double means times 2. And then I'm going to say, okay, a number, which is x. So 12 minus double a number. I'm going to say 12 minus, and the way that we write double a number in algebra is going to be like this. I'm going to put a 2 in front of the x. So I'm saying I have twice the number of x's, so double a number. Sometimes people will write this, x2. That is incorrect. We always want to put this number, which if you remember from elementary school is called the coefficient. We want to put him out front so that we have 2x. All right, and the last one on the page is the difference between a number and 9. Let's go ahead and translate. The difference. Difference is one of those keywords for subtraction. So the difference between, sometimes they kind of go together. So the difference between a number, that's going to be x, and 9. So you see that my x comes first. So I'm looking for the difference between the x and 9. So x minus 9 will be my expression. Okay. Now, there are a couple tricky ones that I wanted to kind of address separately. And the first one is words that use the format of something and something, such as the sum, difference, quotient, or product. What I mean is this. Let's look at the first one. The quotient of a number and 3 minus 5. All right. You'll notice that I have that of and in there. Of something. Of what? Of a number. And what? And 3. So the quotient of a number and 3 minus 5. So if I were to translate this, it would look like, or I'm sorry, if I would annotate it, it would look like this. The quotient of a number and 3 minus 5. So the key thing to know here is this. The and is going to help you place your fraction bar for your quotient. Let me show you what I mean. The quotient of a number, and I'm going to go ahead and use my fraction bar. That and is going to mean my fraction bar. And you can even go ahead and you can put your little fraction bar or your division symbol there to help you remember. So and 3, and then kind of tacking on to the end is your minus 5. Now, let me show you that one in the next one because it's a little bit different. If I annotate the next one, it's going to be the quotient of a number minus 5, there's that and 3. Notice that my and is in a different spot. So the quotient of a number minus 5 and 3. Notice the difference between the first one and the second one. Another tricky area is words that imply grouping. Now, sometimes whenever you're asked to use parentheses, which is how we represent grouping, you'll see two words that actually are used for identifying, adding, subtracting, multiplying, or dividing. For example, 2 times the sum, right, of a number and 5. Do you notice how I have times and sum right next to each other? Sometimes this will indicate that you actually need to group some numbers together. What I want to group is this. I want to say 2 times, and now I'm looking at this piece, the sum of a number and 5. So a number plus 5. 2 times this, what we like to call this piece right here, is a quantity. So 2 times the quantity of x plus 5. All right, a couple more tricky ones. All right, the next one is the phrases that require switching the order of the terms. So you're changing the order of the terms. And I have this little thing I like to remember. From, than, or to, you switcheroo. So if you have any of these words, from, than, or to, you're going to switch it around. Let me show you what I mean. 3 subtracted from a number. Well, let's take a look. 3 subtracted. Now, the symbol that I use for turnaround, because from is a turnaround word, is I actually go like this, and I have a little arrow saying I'm turning it around. And then a number, x. So 3 subtracted from x. So if you look at this, it says 3 minus x, but I actually want to take those pieces and flip their positions. X minus 3. The next one, 5 more than a number. Well, let's look. 5 more than. So plus, than is a switcheroo word, a number x. So 5 plus x, but I have to switch it around. So I'm going to have x plus 5. And then the last one, 6 added to a number. 6 added to, that's my switcheroo word, right? From, then, to, switcheroo. So I got to switch it around. X plus 6. All right, we're almost done with the tricky ones. This is it. the difference between similar phrases such as greater than and is greater than. If you look at those two phrases, the only thing that is different between them is the word is. Now, if you have the word is, that means that it's actually going to be an inequality, meaning it's going to use symbols that look like this. We'll spend a lot more time studying inequalities whenever we get to Unit 6. But for right now, I just want you to know that when you translate, if it has the word is, you're going to use one of those symbols. So 6 greater than a number. You'll notice there's no is. So we're going to go ahead and translate it just like we normally would. We have a little switcheroo word in there. So I'm going to say x plus 6. But then the second one, 6 is greater than. So 6, this right here, that means inequality. So this right here, this greater than, is now going to be a greater than symbol. No switcheroo in this one. That's where it kind of gets confusing. So it's going to be 6 is greater than a number. All right. Now the tricky part is over. All right, here's some you can try on your own. You'll see that I do have the answers here for you, but the other way you have to go is you actually have to take the algebraic expression and you have to move to the verbal expression. So with this one, you could have multiple different answers. Not saying that every answer is correct, but as long as you're using the right vocabulary and the right words, you should be in the right ballpark. For example, number 1, x plus 6. Isn't that going to be a number increased by 6? All right, x plus 6. And then the next one, 3x minus 5. Well, isn't that 5 less than the product, right? The product is multiply of 3 and a number. So I have a little switcheroo in there, so I just switch it around. All right, the next one, I have the quotient of a number. There's my and. My and is my fraction bar. 2, and then I'm going to tack my 4 on the end. Remember, the and is telling you where to place the fraction bar. The next one, the quotient of a number minus 2. There's my and. That's my fraction bar. And then 3 times the difference. Notice here that I have 3, but then I have times the difference. I have those two words, or those two terms that have that mean different operations. So I have the 2 times the difference between a number and 8. So for that one, that's going to be my grouping. And then my last one, 4 is. Anytime you see an is for right now, that's going to be an inequality. So 4 is less than double a number. So is less than, that's going to be my less than symbol. Double, that's going to be our times 2. And then, not a 2, that's going to be an x. So 4 is less than double a number. So at this point, we've translated from algebraic expressions to verbal and verbal to algebraic. So I've got one more thing for you, and we're just going to do a little word problem. I always like to top things off with a word problem. So we're going to construct a table and write an expression to model the situation. We're going to be talking about this in depth in Unit 4 in linear equations, but right now I'm just trying to introduce to you the idea of creating an expression. So while visiting Washington, D.C., you rent a Segway to see the city. You pay $15 for each hour you ride. You also need to rent a helmet for $8. Create a table representing the total cost for 1 hour, 2 hours, 3 hours, and 8 hours you ride around the city in the Segway. So the first thing you always want to do when you have a word problem is define what you're talking about. What 2 things are you comparing here? We like to call those variables. So it looks like we're comparing the hours, H, so I'm going to say hours, and the C, the cost. Now, you don't necessarily have to call them H and C. You can always call them X and Y or any variables as long as you know what the variable represents and you clearly define it. Now it says, write an algebraic expression representing the cost of H hours. So it looks like for every hour, you have to pay $15 to ride the Segway. So the way we're going to represent that is 15 times H. Because if I ride the Segway for 1 hour, it's going to cost me $15. If I ride it for 2 hours, it's going to cost me $30. If I play it for 3, it's going to be $45, and so forth. But you'll notice here, not only do I have to pay the $15 for each hour, I also have to rent a helmet, and the helmet's $8. But I'm not going to rent the helmet over and over for every hour. It's a one-time deal. Sometimes we like to call that one-time purchase a flat rate. I'm going to write that down here. A flat rate. Or sometimes, in the economic world, sometimes this is called a fixed cost. So it's something that you're going to pay once, and it's just done. Okay. So, what we're going to go for that. So, basically what I'm going to do is I'm going to go ahead and add $8. So, what that means is every hour that I ride my Segway, it's going to go up in price. But I'm always going to pay that constant $8. So, let's go ahead and take our expression that we created, and let's go ahead and fill out our table of values. So, here what we want to do is we want to figure out the cost of 1 hour, 2 hour, and 3 hours. So what I want to do is I want to substitute the 1, the 2, and the 3 in for my h. So 15 times 1 plus 8. Well, that's going to give me 23. So over in the table of values, when I rode the Segway for 1 hour, my cost was $23. That seems reasonable. I'm going to go ahead and substitute a 2 in for my hours. So if I spend 2 hours on my Segway, it's going to go ahead and it's going to cost me $38. And if I ride it for 3 hours, it's going to cost me $53. You can see the more time that you're on the Segway, the more it costs you. All right, so we are finished translating expressions, and feel free to go back to this video and pause it and use it as much as you like to help you review the concept.